Rocky. Shh.
Hello, everyone. So today we'll be talking about adding and subtracting algebraic fractions. These are our learning intention for today. We want to know about algebra. We want to be able to simplify algebraic fractions. Essentially, we will be talking about all the different operations in simplifying algebraic fractions, adding, subtracting, multiplying, dividing, and maybe for a few of them would be a combination of them. Okay, and hopefully we'll be able to understand how the rules in adding and subtracting fractions are developed. Okay, so essentially our big question would be, how do I simplify fractions, whether they are fractions that are just numbers or maybe fractions that are algebraic fractions. Okay, now for success criteria, I've probably put here some guide on what you want to target, whether it's emerging, approaching, meeting, and exceeding. And in the exceeding one, essentially what you're actually doing there would be something that the 5.3 students would be doing, which would be adding, subtracting fractions with binomials on the denominators. Okay. So for your home learning for today, I've assigned a task for you to do on Maths Online. So please make sure you log into that. Okay, right. So let's probably have a look at our warm up for today. We've got here, explain the rule for adding and subtracting fractions. And notice here, there are no letters, there are no variables, no pronumerals, and therefore they're just simple fractions that are numbers. Okay, so if we go back to our year 7 or 8, or maybe in year 9, we've revised on them. We want to add 2/3 and 3/4. And it says here, you have there times by 4, times by 4, here times by 3, times by 3. Why do we do that? And therefore end up with 8/12. Adding it to 9/12. Okay, so maybe I'll leave that for you to answer, right? But how do you essentially show that using diagrams, right? So I've got here a rectangle. These are all of the same size holes, right? So that's one hole, another hole, and then you've got here 2 holes. Okay, so we've got here 2/3. How do we make 2/3? Let me just change that color. 2/3 would be if you would have this bit here shaded, right? And what we want to add would be 3/4. We've got shading 3/4 here. I think you'll be shading them better. Let's probably do that better. Okay, hang on. All right, so let's shade 2/3. Let me shade it one at a time, 2/3, right? And the other one is 3/4. So I'll shade 3 of 4 equal parts. I would always emphasize to my students, especially with my year 7s, that it's not just parts, but the key word is shading parts of equal parts. Okay, so now we've got 2/3 on the first one and then 3/4 on the other. Okay, but if we would be saying, well, we want to add them and put them together into this diagram here, we could probably say that, yeah, I could probably do that and divide them into equal parts so that they're the same parts or of the same size as this one, which would be the same as on the other whole. So I'll probably make these divisions here, right? And therefore this one whole part here is of the same size as this one here, because as you noticed a while ago, this one here would not have the same size as the one that's horizontally drawn here or shaded here, right? But what we want to emphasize with fractions is that they are equal parts. You need to make sure that for you to be able to add them, that they are divided into equal parts, and those wholes would be divided into the same equal part as the other, right? So essentially this one here, which was originally 2/3, we could also say that that's 1, 2, 3, 4, 5, 6, 7, 8. and therefore that's 8 over 12, right? And we could say this one here is 1, 2, 3, 4, 5, 6, 7, 8, 9, and therefore that's 9 over 12, right? And so we put them together, we say that's 8 12s plus 9 12s, and that should just give us 8 plus 9, which is 17 12s. So there's 17 parts shaded out of 12 parts here. My question there is, why do you need to rename fractions? We've used this term before, especially when we were talking about fractions, decimals, and percentages. And we said that they are really just renaming these numbers, right? Or writing them into different ways, okay? And maybe you didn't realize that you've been doing that since you were in primary, and that's something really powerful. When you say renaming in mathematics, you'll do that in any stage of mathematics that you will be doing, okay? So you want to make sure that you are able to rename these fractions, these numbers, as to how you want them to function for you. Let's probably have a look at what we want to learn today. Essentially, half of it we've already learned in year 9. So maybe it's something that you want to revise on, right? But what you learned in year 9 is adding and subtracting them, right? But those fractions that would have numerical denominators. So when you say numerical denominators, the denominators would just be numbers, okay? And they're a bit friendly. What you will be learning this year would be those that would probably have, or maybe those that would have numerical denominators, but they would probably look a little more complex than what we were learning then, okay? This one looks very similar, okay? But this is what we want to essentially do this year, something that's new this year, okay? Maybe an extension that you had in year 9 was fractions that would look like these ones, but this one here, this is the meeting step in learning for you to be able to say, yes, I am able to add and subtract fractions in year 10, okay? Now, the one that would probably help you achieve the exceeding bit for this lesson is for you to have a look at what 5.3 course looks like when they are adding and subtracting algebraic fractions, and we'll be looking at those ones later today as well, okay? So let's do them one at a time. When we have x over 2 plus x over 5, similar to our warm-up question, they would have different denominators, and therefore we can't simply add the numerators. We need to rename them, okay? So what we want to do, well, we can't really draw a diagram here because then it wouldn't help us. We don't know what x is. We don't know how many things or parts we would need to shade. And therefore, if you said in the warm-up question, why we multiplied by 4 and why we multiplied by 3 is because what we want to essentially do is to find the least common multiple of the denominators, right? The least common multiple of 3 and 4 is 12, right? And therefore you're renaming these two fractions so that they would have the same denominator, right? So that this one here becomes 12 and that becomes 12, but you don't want to be changing the fraction, right? So you want to think of what number did I multiply to 3 to get 12? It's 4, right? For us not to change the value of that fraction, but rename it, not change the value, we want to multiply by the same number, which is 4, and therefore the top becomes 8. The same thing with the next fraction. What number did you multiply to 4 to get 12? That's 3. That's the same number you multiply to 3, okay? And therefore you have 9 over 12, right? And that's why we got this one here. So let's use that knowledge here for us to figure out what these questions would equal to. So now we've got 2 and 5. What is the least common multiple of 2 and 5? Well, if we list down all the multiples of 2 and 5, right? That becomes 2, 4, 6, 8, 10, 12, etc. And for the multiples of 5, you get 5, 10, 15, etc. Right? And your common multiple is 10, and it's the first one that appears. So now we want to rename that fraction so that the denominator is 10. What did we multiply to 2 to get 10? That's 5, and therefore we multiply the top by 5, we get 5x, right? What did we multiply to 5 to get 10? That's 2, and therefore we multiply the top by 2 as well, we get 2x. 5x plus 2x, you get 7x over 10. Okay, the same thing with the next one. What's the least common multiple of 3 and 7? You have what? 21, and we multiply the bottom by 7 to get 21, and therefore we multiply the top by 7, we get 7y, right? What did we multiply to 7 to get 21? 3, so that we multiply the top by 3, we get 2 times 3, we get 6, and the y, don't forget the y, and we can add 7y and 6y to get 13y over 21. We want to come up with the least common multiple. What's the least common multiple of 5 and 6? It would be 30, right? So then, what did we multiply to 5 to get 30? That's 6. We multiply this whole thing here by 6 as well. So remember your distributive law. You've got 6 times y multiplied by 6, right? So then that becomes 6y plus 6. Yeah. And the same thing with the second one. What did we multiply to 6 to get 30? That's 5. We multiply this bit by 5, right? And remembering to distribute the 5 to each of the terms. Remember, a term is separated by a plus or minus. So therefore, the top becomes 5x plus 5y, right? Now, this one here, you want to collect the like terms. 6y and 5y becomes what? 11y. You've got 5x. Can you find any other terms that would have x? There's none, so it's just 5x and then 6. Now, you can actually write it down as 11y plus 5x plus 6 or plus 6 plus 5x. But which one do you do first? Well, they say mathematicians are lazy, but they are very orderly. So if there is an order for you to be able to write them down so they look nicer, right, then you might want to do the x term first, write down the y term, and then the constant. Okay, so let's do that. We've got 5x plus 11y plus 6 all over 30. So when you want to combine them, or when you write down your answer, I don't know if you noticed it, but they would just be in one fraction. That's one whole fraction or one denominator, right? The same thing with this one here. And for question B, you have 6 and 4. If maybe what you noticed from the beginning is that the LCD is simply multiplying 2 and 5, you get 10. Multiply 3 and 7, you get 21. 5 and 6, you get 30. And that's the same for the next one here, which is 3 and 2. You multiply them, you get 6. This one here is a bit different. You've got 6 times 4, you get 24. You can do that as well, but it might be easier for you to look for the proper least common multiple of 6 and 4. They have a common factor, which is 2, right? What you could probably do is still multiply them 24, but divided by the common factor, which is 2, and therefore the least common multiple is 12, right? So then you have 12 plus over 12. We're renaming this fraction so that the denominator would be 12. What did we multiply to 6 to get 12? It's 2. And then we times this bit by 2, right? And therefore we've got 2x plus 2 using our distributive law. We multiply this by 3 because 4 times 3 gives you 12. And therefore we multiply the top by 3. That gives us 3x plus 12, right? And then collecting the like terms, you've got 2x and 3x, you get 5x. 2 and 12 gives you 14 all over 12, right? And that should be our final answer there. It helps when you circle your final answer, right? It just makes it a little bit clearer, okay? So now let's have a look at those fractions that would have algebraic expressions on the denominator, right? So this time, how do we figure out the LCD of numbers and letters, right? So essentially what you want to look for, just like what we did here, would be to get rid of some common factors. Remember how I told you, you multiply them, but divided by 2 because 2 is a common factor, right? So that you get 6 times 4, you get 24, divided by the common factor, which is 2, and therefore your LCD is 12. We can apply the same strategy here. And that's why we could have what? 3x times 4x, we get 12x squared, but there's a common factor. What's a common factor? It's x. And therefore, if we have 12x squared divided by x, you could cancel out one of the x's, and you could say that the least common multiple of the denominators is 12x. Okay, so again, I hope that you saw there that whatever applies for fractions, just numbers, it also applies to these algebraic fractions, because remember, all these pronumerals are just numbers. They're just placeholders to your numbers. So whatever works for numbers, it also works for algebra. Okay, so we've got 12x. What did you multiply to 3x to get 12x? It's 4. Therefore, you multiply the top by 4, you get 8. Yeah, 4x times something gives you 12x. You multiply it by 3, and therefore you multiply the top by 3, you get 3. 8 minus 3 gives you 5. That's 5 over 12x. Okay, now if you want to just maybe trial out the questions, I've already given you the task on Jacaranda, which is exercise 7.3, right? And when you finish that, and maybe you say, let me try and see if I can extend myself and have a look at what 5.3 course looks like. Okay, so I've added here a screen so that there's space for us to write down this example here. This is the extension bit. This is what the 5.3 course would be doing. So let's write them down here. Just like what we were doing a while ago, we want to figure out the LCD. And what we said was that the LCD is simply multiplying them and then dividing it by the common factor, right? So we multiply the x plus 3 and x plus 2, so that's equal to what? Maybe that's too long. That's x plus 3, x plus 2, and then plus x plus 3, x plus 2. And notice that I did not actually multiply them using the FOIL method. Just leave it as binomials, okay? Now, what did we multiply to x plus 3 for us to get x plus 3 times x plus 2? And looking at this one, it's just x plus 2, right? So therefore, what we want to multiply the top as well would just be x plus 2, right? Because that's what we multiplied the bottom, right? For us to get x plus 2. Remember, we're renaming this fraction, right? And therefore, the top becomes what? X plus 1, x plus 2. Yeah, and then the same thing with the other one. What did we multiply to x plus 2 to get x plus 3 times x plus 2? It's the one missing here, which is x plus 3. So let's go and do that on top. We've got 2x minus 1, x plus 3. Okay, so, well, we can't really do anything here if we don't expand the top, right? So we need to expand the top first using our FOIL method. We have first terms first. You've got x squared, or x times x is x squared. Outer terms and inner terms would add together. So that's 1x plus 2x. We get 3x. And then the last terms, which is 1 times 2, you get 2 over x plus 3, x plus 2. Okay, the same thing with the next one. We use the FOIL method, 2x times x, that's 2x squared. We use the outer and the inner. We add them together. We have negative 1x plus 6x, we get 5x. And then negative 1 times 3, you get negative 3, right? Over x plus 3, x plus 2. Okay, now we can combine the like terms. We've got x squared plus 2x squared. We have 3x squared plus 8x minus 1 all over x plus 3, x plus 2. That's our answer there. Now, maybe you could say, let me find out if I could factorize this, and maybe some of those factors, or one of the binomials, would end up canceling the other. Let's try. We've got the AC test. We've got 3x squared times negative 1. That's negative 3x squared. You have any factors of negative 3 that when you add, you get 8. I don't think so. And therefore, you just leave it as such, 3x squared plus 8x minus 1. Let's rename the two fractions. They don't have the same denominator, but look at that. They look similar, right? So what would be our LCD here? We said we multiply them, but divided by the common factor. So if we multiply them, get x minus 3, the bracket cubed, but we want to divide it by x minus 3. So essentially, what we have as our denominator, or least common denominator, is x minus 3 squared, right? So let's write it out, x minus 3 squared. Okay, what did we multiply to x minus 3 to get x minus 3 squared? It's one of the x minus 3s. So the top becomes x plus 2, x minus 3. Yeah. What did we multiply to this to get that? Well, 1. Therefore, we don't have to change this. We don't have to rename this because we already have the desired denominator, which is x minus 3 squared. So we just write the top x minus 1. Yeah. So you don't stop here. You want to expand the numerator here. So that becomes x squared. 2x minus 3x would give you minus x minus 6 over x minus 3 squared plus x minus 1 over x minus 3 squared, right? And therefore, we've got x squared, what's minus x plus x, that becomes 0. Minus 6 minus 7 gives you minus 6 minus 1 gives you minus 7, right? And therefore, you've got the denominator x minus 3 squared. So I hope that gave you an idea of how to show or demonstrate what's exceeding in this lesson. And for you to be able to demonstrate that, show that in your work, is for you to have a look at those questions from questions 4 to 11 of the exercise, right? And then just maybe choose any 3 of them, right? And don't forget to write your exit ticket for today. Write 3 things you learned about algebraic fractions, 2 interesting things you learned about simplifying algebraic fractions. What did you learn about adding, subtracting fractions, right? And then 1 question that you still have. Okay, I hope that helps. I'll see you next lesson. You stay awesome. Bye.
Come on, Rocky, let's go.